All right, here's an example of the type of problem you might run into for the first learning objective for vectors. Here's a picture of 4 different vectors in the Cartesian plane. Notice our angles are both defined relative to the x-axis and the y-axis, so we have to be careful when we're writing the components that we use the correct trig function. And also the question doesn't actually ask us to add all the vectors, we're only adding 3 of them, so you have to be careful that we're paying attention. The first thing we're going to do is we're going to write all the different components of the vectors. So bx. Now b has a magnitude of 15 and it makes an angle of 30 degrees with the y-axis. So when we think about bx and by, we have to keep in mind that we want to use the correct trig function in order to find those components. Because of the way the angle is defined, the x-axis is actually found by using the sine of 30 degrees, which would be 50, and so we get 15 times the sine of 30. So the x component is 7.5 meters. When we do the y component, we were looking at the adjacent side, because I could also write by here, and the adjacent side involves the cosine function. So this will be equal to b cosine of 30, which is 15 cosine of 30, which turns out to be 12.99 meters. When I'm looking at the components of vector c, the angle is measured relative to the negative x-axis, so my components cy and cx are going to be defined sort of in the normal way that we usually think of the x and y components. The x component is the adjacent side to the angle, so we'll use the cosine. The y component is the opposite side from the angle, so we'll use the sine. But in this case, we also have to be careful because the x and the y components are both negative. And so we want to make sure that we put in that negative sign. So it's minus 12 times the cosine of 25. So the x component is minus 10.88 meters. And the y component is minus 10 times the sine of 25. And that's going to give us minus 5.07 meters. Finally, we're going to do the components for the x and y components of vector d. Again, cx and cy. Now, again, our angle is measured relative to the y-axis, and notice that our x component is opposite the angle and our y component is adjacent to it. So our y component is going to be given by d times the sine of 53, which is 10 sine 53, and it's negative. Almost forgot that because it's pointing to the left, so it's minus 7.99 meters. The y component's positive, it's adjacent, so we use the cosine, and we find 6.02 is the y component. Now I have to add all my x components together to find the x component of the resulting vector. And I find that that's minus 11.37 meters. I'll do the same thing with the y components. And I find the y component is 13.94 meters. Just to notice, what I found is that my x component is negative and my y component is positive. So my vector r looks somewhere, it's over in the third quadrant. To find the magnitude of r, I use the Pythagorean theorem and square the x and y components together, and then take the square root.
And that was so overwhelming. She was just throwing information at me, and I was trying to write it all down, but also comprehend.
And then finally, we need to find the angle.
I feel like that's all.
We use the inverse tangent, which is found of the angle is the y component over the x component for the vector. We should use the fact that the x component is negative. And this will lead us to get a negative reference angle. But we use this to help us. We know if we want to find the direction of the angle this way, it should be 180 minus the 50.8, or we could also say it's 50.8 measured from the negative x-axis. So I could say vector r has a magnitude of 17.99 meters. Theta is 129.2 degrees measured counterclockwise from the positive x-axis. Or I could say theta was 50.8 degrees clockwise from the negative x-axis. But keep in mind that no matter what, when I'm talking about a vector, I have to make sure that I talk about both its magnitude and its direction. When it's written in unit vector form, I can actually just keep it in unit vector form, but that would be a different problem.